Why are there stones along railway tracks? You've probably seen them. Millions of rough, gray, jagged stones stretching alongside railroad tracks for miles and miles. Most people notice them. Very few people ever think about them, and even fewer know what they're actually there for. No matter where you are, Britain, the United States, or almost anywhere else with railroads, those stones are always there. But why? Why do we place some of the world's most advanced trains on what appears to be nothing more than a giant pile of loose rocks? Why not simply anchor the tracks to a solid concrete foundation? The answer isn't just about saving money. It's actually a remarkably clever engineering solution that prevents railroad tracks from sinking into the ground. And it hides a fascinating history that connects modern railroads to ancient sailing ships. Welcome to High Simple Things. Today, we're uncovering the secret behind those railroad stones. To understand why they're there, we first need to understand the problem they're solving. Trains are incredibly heavy. Some freight trains can weigh more than 40 million pounds, or over 18,000 tons. And all of that weight is transferred to the rails through a relatively small contact area between the steel wheels and the steel track. If railroad tracks were placed directly on the ground, the soil underneath would gradually compress under the enormous pressure. The rails would begin to sink. The track would become uneven. And over time, the risk of derailment would increase. Engineers needed a way to spread that enormous weight across a much larger area. That's where the stones come in. Their technical name is ballast. A railroad track is built in layers. At the top are the steel rails. Beneath them are wooden or concrete ties. And underneath the ties is a thick layer of crushed stone known as ballast. Instead of concentrating all the weight in one small area, it distributes the load across a much larger surface. This prevents the ground beneath the track from becoming overloaded or collapsing. But supporting weight is only part of its job. Here's what surprises most people. Unlike buildings, railroad tracks aren't anchored deep into concrete foundations. In many ways, it's the ballast itself that keeps the entire system in place. The stones create friction, provide stability, and help keep the rails properly aligned. At first, that might sound less secure than concrete. But that flexibility is actually one of the system's greatest advantages. Every passing train creates vibration. If the structure were completely rigid, much of that energy would be transferred directly into the track. The ballast allows the system to move by a tiny amount. Not enough to affect safety. Just enough to absorb some of the vibration and reduce wear over time. It's a simple solution that has helped railroads operate reliably for decades. But if you've ever looked closely at railroad ballast, you may have noticed something unusual. The stones aren't smooth. They're sharp, jagged, and that's completely intentional. Why? Why not use smooth river rocks? Imagine standing on a pile of marbles. Everything would roll beneath your feet. Now imagine standing on a pile of broken stones. The rocks lock together. They resist movement. And that's exactly what engineers want. Railroad ballast is typically made from hard crushed rock such as granite. The sharp edges interlock with one another, creating a stable foundation. Instead of rolling around, the stones help hold the track firmly in place. Even when massive trains pass over it every single day. But these rocks do more than support weight and maintain stability. They also help solve two major problems: water and weeds. Rainwater can be a serious threat to any railroad. If water accumulates around the track, the soil underneath can become soft and unstable. Over time, the track may begin to shift. The gaps between ballast stones create a natural drainage system. Water quickly flows through the spaces between the rocks and drains away. The ground stays drier. The foundation stays stronger. Then there are weeds. At first glance, plants may seem harmless. But roots can gradually weaken the soil beneath the track. The thick layer of ballast makes it difficult for most vegetation to grow. There is very little soil, very little moisture near the surface, and very few opportunities for roots to take hold. As a result, the track remains more stable and easier to maintain. So these stones are doing several jobs at once: supporting weight, reducing vibration, providing drainage, and limiting unwanted vegetation. Not bad for something most people barely notice. But there's one more fascinating detail. The word ballast didn't originally come from railroads. It came from the world of sailing ships. Centuries ago, Sailing vessels often carried heavy material in their lower compartments when they weren't transporting cargo. That extra weight helped keep the ship stable in rough seas. This stabilizing weight was called ballast. Today, ships no longer rely on piles of rocks. Instead, they use specially designed ballast tanks filled with water, which are far more practical and effective for modern vessels. But the name remained. When railroads adopted crushed stone to stabilize their tracks, they borrowed the same term because both systems served the same purpose, providing stability. And the name has survived ever since. So the next time you see a railroad track, don't just look at the train. Look underneath. Those rough gray stones aren't there by accident. They spread the weight of trains that can weigh tens of thousands of tons. They absorb vibration. They drain water. They help prevent vegetation from taking over. And for more than 200 years, they've quietly helped keep railroads operating safely around the world. Not because they're simple, but because they're remarkably effective. If you enjoyed this story, be sure to subscribe for more hidden engineering secrets behind the everyday things we often take for granted. Thanks for watching.